Hello to everyone. Welcome to our YouTube channel Sethi Civil. In today's session, for on electric charge and fields, application of Gauss's theorem to find electric field or electric flux of one dimension, two dimension, three dimension objects. These are very important for this. In earlier session, we discussed electric charge and field charge property in Coulomb's law, electric charge and field 2, all electric field due to dipole, axial equatorial at any position, Gauss's theorem application, and charge 3. Two formulas which are directly applicable, but concepts are clear, which are very important for the JEE Main, JEE Advanced, NEET, and other entrance examinations. Now, let's start with the question. Question is the total flux of the electrostatic field through the sphere S1 and S2. We have to fill in the blanks. Total flux through sphere S1 and S2. Here is wire AB. The wire AB shown in the figure as a linear charge density lambda, given by lambda equal to kx, which linear charge density dependent on the distance, where x is the distance measured along the wire from A is. Now, we know the formula. Electric flux. Flux is given by 1 over epsilon naught into charge enclosed. This is the formula. So flux through S1 will be equal to 1 over epsilon naught Q, and flux through S2 will be equal to 1 over epsilon naught Q plus Q. This is the charge due to AB. Right? Now, our purpose is to find charge on AB. Right? In this case, because line is AB is one-dimensional object, therefore dq will be equal to lambda dx. Linear charge density is given to, that is kx dx. Therefore total charge dq will be equal to 0 to L kx dx. Right? Now this comes out to be kl square by 2, that is q. Therefore total flux through S2. Flux through S2 will be equal to 1 over epsilon naught Q plus 1 by 2 KL square. This is the answer. We have to fill in the blanks. This one. Next question. Question is, a spherical symmetric charge distribution considered with the charge density varying as this. To find the electric field at point P. Point P lies inside. That is, R is less than the radius of the sphere. Right? Now, sphere, this is a three-dimensional object. We know the concept applicable for 1D, lambda dl, 2D, sigma ds, and 3D, rho dV. These are the standard. First of all, identify this. Now, our purpose is to find the electric field. To find the electric field, you have to use Gauss's theorem. E dot ds, that will be equal to 1 over epsilon naught Q. Main purpose is to find the Q. If we know this, because electric field direction will be outside, so angle will be, area vector is 0. So E into 4 pi r square equal to 1 over epsilon naught. You have to put the value, then that is the answer. That will be the answer. Now to find Q. To find Q, simple, dq will be equal to rho r dV. Right? Therefore total charge dq will be equal to rho r. Rho r की value put कर दी, rho naught 3 by 4 minus r by r into 4 pi r square dr, right? 4 pi r square dr. Now, integrating 0 to r. So this comes out to rho naught into 4 pi, taken common, 3 by 4 r square minus r cube by r. This comes out to be. Now integrating this 0 to r. On integration, this comes out to be 3 by 4 r cube by 3. 3 by 4 r cube by 3. 3 by 4 r cube by 3 r cube by 3 into 3 by 4 here. 3 by 4 minus r4 by 4. R4 by 4 into r. Right? This comes out to be the answer. In the rho naught 4 pi. Rho naught into 4 pi. This is Q. Right? 4 pi rho naught this is 3 by 4. So this 3 goes, the balance is r cube by 4 minus r4 by 4r. If we take r cube common and 4 common, this 4 goes pi rho naught r cube. This comes out to be 1 minus r upon capital R cube. Substituting in equation 1. Equation 1 is E into 4 pi r square equal to 1 over epsilon naught pi rho naught r cube 1 minus r over r. This comes out to be further. This pi goes. This pi goes, and r square, this r square goes to rho naught r upon, this comes to 4 epsilon naught, 4 pi epsilon naught. Answer is 4 epsilon, yes. 4 epsilon naught, 1 minus r upon r. Check the answer. Check the answer. This is the electric field, right? I think rho naught over r, 4 epsilon naught, 1 minus r by r. C is the correct option. In this case, I am again Gauss's theorem E dot ds equal to 1 over epsilon naught q. To find this, as the given object is 3-dimensional, using the concept of rho dv. Rho dv में लगा दिया. इसके बाद, in this case, electric field is readily, whether it is positive or negative. So electric field is positive. Outward area vector will be, so theta will be 0, cos 0 is 1. E dot ds, that is E into 4 pi r square, put the value after integration, that will be the final answer. Now, I will request, if you are new to my YouTube channel, Sethi Shift Learn, please like and subscribe to my channel, press bell icon to receive updates on concept killing videos. Thank you, धन्यवाद, बहुत बहुत धन्यवाद.